All right, consider the function f of x equals absolute value of x over x. So before we proceed with that function, let's look at just the absolute value function for a second here. You've seen this function before. If we're looking at, I'm going to call this g of x equals absolute value of x. Absolute value, remember, is the distance from 0. So if you'd put 0 in there, distance from 0 is 0. If you'd put 1 in, you'd get 1, 2, you get 2, and so on. So this side's going to look like that. However, if we put a negative number in the absolute value of x, you would get a positive number because it's the distance from 0. So absolute value of negative 1 is 1. Negative 2 would be 2, and so on. So that side looks like that. So absolute value function is actually a piecewise function here, where on this side, that's just the line y equals x. But on the other side, that's y equals the opposite of that function, so the opposite of x. So if we were to do this, what is the limit of 0? Well, remember to check this function here. We're going to need to check both sides. What's happening as we approach from both sides? So what happens as we approach from the left side of this? Well, the limit as we approach 0 from the left side here, of the absolute value of x over x would be equal to, notice that as you approach from the left, that's this side, that's the function negative x. So this would actually be equal to then negative x over x, which, if we cancel out those x's, because they're the same number, would end up equaling negative 1. So that would equal negative 1 there. If we did it from the positive side, though, if we approach from the positive side, that's the graph of x. And so if we did limit as x approaches 0 from the positive side of absolute value of x over x, on the positive side, absolute value is just the function x, which, if we cancel out these same numbers, is going to give us positive 1. So noticing that those are not the same, these one-sided limits are not equal here, we say that this limit does not exist, which means that there's not one piecewise answer for this limit. This function here does not have a limit. Let's look at some other absolute value ones and see if we can answer here. So what is the limit as we approach 2 from the negative side of this absolute value function here over x minus 2? Well, we can't simply plug in 2 on this one to figure it out, because 2 minus 2 is 0, and 2 minus 2 is 0. We get 0 over 0. You can't divide by 0, so that won't work. And so what we got to do is look at, from the negative side, what's this function going to behave like? That's going to behave then like the opposite of that function, which the opposite of that function would be the opposite of x minus 2, which, if we go through and distribute this negative here, you could do that, or we could also notice that, probably easier way to do that, notice that we do have the same function both on top and bottom here, and so we could cancel that out, but that does leave this then to equal a negative 1. How about if we approach from the positive side? Well, from the positive side, the absolute value of this is just going to act like the function itself, so it's going to act like x minus 2. So here, canceling out on this one, this is going to approach positive 1. So what is the limit of this function as we approach 2? Well, you notice, did the two sides match up? Nope. And so what would we write for this one? This limit then does not exist, because left and right side are not matching up. All right, find each of the following limits. This is a piecewise function, and so on piecewise functions, what you want to do here is check where does it change. And looking at this one, we can see that this piecewise function looks like it changes at 1. And notice our limit, that is our point we're approaching here. So we're approaching that changeover point, which might not lead to a limit. Even though both of these functions are continuous themselves, at 1 we're unsure. So let's check and see. As we approach from the left, which one of these two functions would we be using? Well, from the left, that would be when this function's less than 1. Here's our qualifier up here that says less than 1. And so if we're going to figure out what the value is at 1 here, we would want to use this function right here. And so this would be the same as the limit approaching 1 from the left of 2x minus 1, which we can substitute that 1 in there to figure this out. And this is going to equal 1. From the right, that's when the numbers are bigger than 1. That's going to be this qualifier here. And so this function on the right is going to behave like that function. And so to figure this one out, we can do the limit as we approach 1 from the right of 3x plus 1, which, substituting in 1 here to figure it out, looks like it's going to equal 4. Did those match up? No, they did not. The left and right are not equaling, and so this limit also does not exist. So you got to make sure that they are matching. All right. Why don't you pause the video and try this example out on your own and see what you come up with. All right, let's check it. For this one, if you what is k at -2, meaning you want to plug in -2. To do this one, you'd want to see, okay, which of these qualifiers here actually equals 2. Well, neither of them do. This function is not defined at -2, and so you hopefully put that this does not exist. There is no point at -2 on this one. What is it as we approach -2 from the left? You should have chosen the top function for this one because that's where it's less than -2. And so to do this one, you'd want to plug in -2 into that function to figure it out. -2 squared is 4, minus 1 would end up being 3. So you should have gotten 3 for that. For the bottom one, where is it approaching -2 from the right? That would have been the same as this function, which at -2 is going to be -2 plus 5, or 3. So does the limit as we approach -2 work for this one? On this one, they were both 3's. Both sides approach 3, so this does have a limit that equals 3. Even though that there's no value at -2, it looks like the graph is approaching the same thing of 3, but it looks like there is a hole there. All right.